Welcome! You will now learn how to use configuration software and create a strategy for managing your AMIs. You can simplify many common administrative tasks with a configuration server, such as AWS OpsWorks with Chef or Puppet. The most common example is provisioning and deleting user access to EC2 instances. For example, say you give access to a fleet of EC2 instances to a consultant. You give the consultant a private key to log in with your user ID and perform administrative tasks on these instances. What happens if the consultant leaves the company? Without a configuration server, deprovisioning access to these machines can be a manual and complicated process. However, using a configuration server, a system administrator can use a few simple commands to easily change access to the system. They can also apply this change to all instances in the fleet. One advantage of using a configuration server is that resource creation and configuration happens once and only once. If manual modifications are made to the configuration of an instance, the configuration server detects those changes and rolls them back. This helps ensure that the integrity of the instance isn't compromised by accident. It's common for organizations to need a pre-installed base set of software on all EC2 instances. This software might include utilities developed by the organization, in-house tools for using AWS services, and advanced software for enterprise-scale activities such as monitoring and intrusion detection. You can satisfy this requirement by creating a custom AMI as a base configuration. First, you launch an EC2 instance from a standard prefabricated AMI and pre-configure all the software that your organization needs for that instance. You then create a custom AMI from it. The new custom AMI now becomes the AMI that will be used to create all new instances in the organization. As a way to maintain consistency, you can create a process that scans the running EC2 instances. The process enforces a policy that all new instances are launched only from the new base AMI. It will terminate any instances that are not using the standard AMIs. Another option is to configure instances at boot time. For example, you can use the user data option to run a script when you launch an EC2 instance. Discovering the ideal approach to AMI management means that you must consider the trade-offs between simplicity and flexibility. A fully baked AMI boots faster but takes longer to produce and build. A plain AMI that uses user data will take a long time to boot due to the installs that take place during launch. The more complex an AMI is, the greater the risk that your application will be vulnerable to a security issue. Security updates to all items in the AMI will need to be applied on a regular basis. The goal is to find the right combination of trade-offs for your organization. For more information, search for AWS AMI Design in the AWS documentation. You can create an AMI with the AWS Management Console, the AWS CLI, or with the AWS API. The resulting AMI exists only in the region in which it was created. For example, if you create an AMI from an EC2 instance that runs in the EU West 2 region, the resulting AMI will exist in the EU West 2 region. You can't then launch a new instance from the AMI in a different region. You have to copy the AMI to the region before you can use it. By default, when you create an AMI from an instance, the instance will be rebooted to ensure consistency. You can override this default behavior. However, if you choose this option, the integrity of the file system of the created image cannot be guaranteed. Also, if you create an AMI from an EC2 instance that has additional volumes attached to it, the attached volumes are captured as part of the process of creating the AMI. The command line call shown here demonstrates how to create an AMI. When you use the create image command, you must specify the instance ID and also specify a name for the AMI that will be created. You can copy an AMI to a different region by using the AWS Management Console, AWS CLI, or the Amazon EC2 API. In this AWS CLI example, the source image ID and source region are both specified. Also, the region parameter identifies the region where the AMI will be copied to. The command also specifies the name to assign to the AMI that will be created. The storage type of the AMI does not matter to the copy image command. You can copy AMIs backed by Amazon Elastic Block Store and AMIs backed by instance stores. For more information, search for copying AMIs in the AWS documentation. When you create an AMI, Amazon EC2 creates snapshots of your instance's root volume and any other EBS volumes attached to your instance. You're charged for the snapshots until you deregister the AMI and delete the snapshots. You can also create Linux AMIs directly from the EC2 instance root volume snapshot by running the AWS EC2 register image CLI command. This is the type of process you'll want to investigate by using the documentation. EC2 Launch v2 is available by download, by installation from SSM Distributor, and on all supported Windows AMIs. It runs as a Windows service on the instance. EC2 Launch v2 performs tasks during instance startup and runs if an instance is stopped and later started, or if it is restarted. It can also perform tasks on demand. Some of these tasks are automatically enabled, while others must be enabled manually. You can change the default settings using the EC2 Launch v2 settings dialog box, which can be launched from the Windows Start menu. You can also configure it using the EC2 Launch CLI command. Among other tasks, the EC2 Launch v2 service runs Microsoft sysprep. Sysprep removes system-specific information. When EC2 Launch v2 calls sysprep, it uses program data to determine which operations to perform. The EC2 Launch v2 service supports all EC2 config and EC2 Launch version 1 features. EC2 Launch v2 uses a configuration file to control its operation. You can update the configuration file using either a graphical tool or by directly editing using a YAML editor or a text editor. Here are the three sysprep phases. First, the tool removes image-specific information and configurations. For example, sysprep removes the security identifier. After this phase completes, the operating system is ready to create an image. In the specialize phase, plug-and-play scans the computer and installs drivers for any detected devices. The tool generates OS requirements like the computer name and SID. You can also run commands in this phase. In the final phase, the system runs an abbreviated version of Windows setup. It asks the user to enter information such as system language and time zone and a registered organization. When you run sysprep with EC2 config, the answer file automates this phase. Thanks for watching. See you in the next video. Welcome. You will now learn about Amazon EC2 launch templates. Launch templates streamline and simplify the launch process for Amazon EC2 instances that can be used for automatic scaling, spot instances, and on-demand instance deployment. They also reduce the number of steps for creating an instance by capturing all launch parameters in one resource. Launch templates help manage costs, improve security, and minimize the risk of deployment errors. You can specify the instance type, the subnet to launch the instance into, the key pair to assign, and the security group to apply to the instance. Launch templates also support versioning. A launch template can have multiple versions. Each version can have different launch parameters. When you launch an instance from a launch template, you can use any version of the launch template. If you do not specify a version, the default version is used. You can set any version of the template as the default version. By default, it's the first version you create. In the diagram, the launch template has three versions. This diagram shows the typical life cycle of computing infrastructure resources in an organization. In the resource provisioning phase, administrators provision resources according to the business needs. During the configuration management phase, resources become components of a configuration management system that supports activities like upgrading, tuning, and patching. During monitoring and performance, tools validate the operational status of the resources by examining metrics, transactions, and log files. Compliance and governance frameworks ensure alignments with standards and regulatory requirements. Finally, the resource optimization phase is when administrators review performance data. They then identify changes for optimizing the environment for performance and cost management. In each stage, procedures can use code, which extends the benefit of IAC to manage the entire resource lifecycle. Every part of the lifecycle benefits from the consistency and repeatability that IAC offers. Resource provisioning is the first phase of the information resource lifecycle. You need a repeatable process for instantiating resources consistently. For example, you might need to build a replica of a cloud-based production environment in a different location for the purposes of disaster recovery. A service such as AWS CloudFormation enables you to provision multiple copies of the same environment consistently. Infrastructure as code provides the framework for this process. After you provision your infrastructure resources, you must address the ongoing configuration management of the environment. You might need to deploy a version of an application across a group of servers and perform a rollback if there are problems. Or you might receive a request to install a new operating system package in a developer environment, but to leave the other environments untouched. Amazon EC2 Systems Manager enables you to define an action that is performed in one or more instances. This puts a higher level of efficiency to manage large-scale environments. The tasks are run and results are returned as success, failure, or any other error. AWS OpsWorks is a configuration management service compatible with Chef and Puppet. You also must have a way to maintain infrastructure health. For example, if you host a web application that experiences occasional spikes in traffic, you must make sure customers don't experience timeouts. It's important to capture key metrics to assess the health of the environment and take corrective action when problems arise. Metrics provide visibility. With metrics, your organization can respond automatically to events. Without metrics, your organization does not know what's happening in its infrastructure. It can be difficult to capture the relevant metrics and logs when you have a scalable and loosely coupled system written in multiple languages and frameworks. Amazon CloudWatch provides the flexibility to maintain infrastructure health. Technology governance and compliance is the fourth major area where IAC can have an impact. You need visibility into your infrastructures to address industry or regulatory requirements. The dynamic provisioning capabilities of the cloud pose special challenges because visibility and governance must be maintained when resources are added, removed, or updated. For example, if you add a user to a privileged administration group, you must be able to explain when this occurred. Although you might have visibility into the current state of your AWS resource configurations, you must also track how these resources change over time. AWS Config is the service that can provide for versioning and change management of your implementation. Resource optimization is the final stage in the information resource lifecycle. In this stage, you review the performance data and identify the changes that you need to optimize the environment. These changes fall into the categories of security, performance, and cost management. It's important for all application stakeholders to regularly evaluate the infrastructure to determine if it's being used optimally. You must be able to answer questions like, are any resources underused? Or how can the charges associated with the operating environment be reduced? To answer these questions, you need a way to investigate the operating environment, retrieve data related to optimization, and use that data to make meaningful decisions. AWS Trusted Advisor guides you on how to answer these questions. In summary, by using infrastructure as code, your organization can automatically deploy consistently built, secure, and reliable environments. Thanks for watching. See you in the next video.
Welcome. In this demonstration, we're in the AWS Management Console in the AWS Academy sandbox environment, and we're going to look at launch templates. So to get to launch templates, I'm going to go ahead and highlight EC2, click on that link, which will take me to the EC2 console. On the left-hand side, under Instances is Launch Templates. I'm going to go ahead and click Launch Templates. Now, what is the benefit of a launch template? I can configure an EC2 instance just the way I want it and create this template so that whoever deploys from this template will have a consistent machine. So in this case, I can decide what Amazon machine image we're using. I can go ahead and define things like security groups. I can tag the instance. All of this and more can be set up. So we'll go ahead and look at that. So let's jump into creating a launch template. And it brings up the Create Launch Template window. Now, I need to give the name of my template. In this case, I'm just going to choose the default, which is my template. And you could give this the name of the application that is in that machine. You can give it whatever the specifics are so that your administrators know what this particular template is. And then I'm going to choose that it's the template version 1. So I can make changes to templates, and in making those changes, then I can ensure that people use the latest and greatest template. I'm going to scroll down and look under the Amazon machine image. I'm going to go ahead and we're going to choose the Amazon Linux 2 AMI. And then I can choose the instance type. And in this case, I'm going to choose the T2 Micro, which is free tier eligible for this particular demonstration. And then I'm going to select a key pair login. Now there's a login key pair that's created when this sandbox environment is created. So I'm just going to go ahead and choose the default. For the networking platform, I can go ahead and use the VPC, the Virtual Private Cloud, or the older EC2 Classic network for backwards compatibility if you've been an Amazon customer for a while. I can then choose the security group. So in this case, default VPC. I'm going to go ahead and choose that, but again, I can choose the VPC, whether that VPC is public or private, and then it has the storage volumes. In this case, that AMI, that Amazon machine image that I chose, comes with one volume. It's 8 GB, and it's a general purpose SSD or a GP2 drive. So I can add additional volumes depending upon how I wanted to structure this particular machine, whatever the needs happen to be. And then I can go ahead and set up a resource tag. There I have the ability to set up 50. In this case, just going to set up one and call that the name, my template. Tags are good for organizing and for targeting what particular EC2 instances are being used, and you can search on tags. You can go ahead and apply patches based on tags. You apply software updates based on tags. So there's a whole host of different things that you can do with tags. I can add a network interface if I'd like. And in this case, I'm not going to. I'm just going to go ahead and click Create Launch Template. Now it's gone ahead. It says it successfully completed my template. So I'm going to go ahead and look at that template. It shows up and I have all the details. And of course, no surprise here in terms of what we see, because this is what we configured when we created the template. Notice I have my launch template here called my template, and I can go ahead and launch an instance from the template. I can also, if I'm on the instances, I can go ahead and, again, from launch instance from template. So until you create a template, this is grayed out. But after you create your first template, it's available. And in this case, I can give a source template. So I can, if I have multiple templates, a catalog shows up and allows your users to go ahead and pick the particular template they need. I can define the number of instances. In this case, we only have one version of the template, but if I had multiple versions, they would be there. So depending upon the software, maybe my software that we install on this particular template works with a particular OS with a certain set of patches. I can go ahead and test that out. I have my Amazon machine image. By the way, I'm just going to create one instance. The instance type, again, the key pair. Again, I can go ahead and choose that. I can choose the network as well as the subnet if I choose. Multiple subnets here. I'm going to go ahead and choose the top one. My security group, again, I can choose, we just have one, but if I had multiple, I could change that. So there is flexibility when you have the template. You can use it to guide your users in the creation of EC2 instances, but you can also have it rigid or have it flexible in terms of what they need. So again, I just have the one volume. I could add additional volumes here and click the resource tags. And then it's simply launch the instance from the template. That's going to take a little bit, but this concludes our particular demonstration, and I hope you learned how you can effectively use launch templates in your environment. Thank you.
Hello and welcome. You will now learn about the continuous integration and continuous deployment process. Continuous integration, also known as CI, is a DevOps software development practice where developers regularly merge their code changes into a central repository. After developers merge their code, they run an automatic build and test. CI is an approach that needs the software development team to adjust their practices and learn how to integrate frequently. In the diagram, version 1 of some code is checked into a source control system. The service then automatically builds and runs unit tests on the new code. These tests immediately discover any errors in the staging area. After the code is tested successfully, it is released to production. With continuous delivery, also known as CD, code changes are automatically built, tested, and prepared for release to production. CD expands on CI by deploying all code changes to a testing environment or a production environment. Using the CI/CD approach, committed reviews trigger an automatic flow that builds, tests, and stages updates. A developer still makes the final decision to deploy to production. This approach benefits software development teams because they can find and deal with bugs quickly, improve software quality, and reduce the time it takes to validate and release new software updates. The 4 basic stages of software development are code, build, test, and deploy. During the code phase, you check changes into a source code repository. During the build phase, source code is built, the quality of the code is tested on the build machine. Quality tests are generally automated. The goal of the test phase is to perform tests that cannot be done during the build phase. In this phase, the software is deployed to a production-like environment. Often these tests include integration with other systems, load testing, user interface testing, and security testing. Teams may deploy to pre-production stages where their application interact with other systems. These processes help to ensure that the new software actually works. The deployed phase is where code is made available for use. Different teams have different deployment strategies, but the goal is to reduce the risk and minimize the impact of any potential errors. When you work with a monolithic application, many developers push changes through a shared release pipeline. This causes friction at many points in the lifecycle. During development, engineers must coordinate their changes to make sure they don't break someone else's code. For example, if you want to upgrade a shared library to use a new feature, you must convince everyone else to upgrade to the same library at the same time. Likewise, if you want to quickly push an important fix for your feature, you must still merge it with everyone else's existing code before testing. You also need to compile the entire application, and this leads to merge Fridays, or even worse, merge weeks, where all the developers need to compile their changes, resolve any conflicts for the next release. Even after development, you face overhead when you push changes through your delivery pipeline. You must rebuild the entire application, run all the test suite to make sure that there are no issues, and redeploy the entire application. For a fast-growing company trying to innovate and compete, this overhead and slowness is not ideal. Without CI/CD, the build, test, and release process involves manual work that can introduce unnecessary delays. For example, developers may use tickets or email messages to track a release process. Other developers then typically receive these tickets or email messages that request that they run a particular build or test. At this point, many requests may become backlogged and cause more delays. After a build is completed, new tickets must be opened to deploy the software. All these requests can increase the time it takes for a change to reach production. Here's an example of how you can increase efficiency with a service-based software delivery model. Every service has an independent delivery pipeline with service-based application development teams that are decoupled. Each team has the tools to efficiently release changes to their own service. AWS Code Commit is a fully managed service control system that hosts secure Git repositories. With Code Commit, you can collaborate on code in a secure and highly scalable ecosystem. Code Commit reduces the need to operate your own source control system or worry about scaling its infrastructure. You can securely store assets from source code binaries, and it works seamlessly with your existing Git tools. As seen in the diagram, Jenkins is an open-source automation software predominantly used for CI/CD. The Postman application is a convenient tool for testing a REST-based API. Back in 2001, Amazon had a problem. The e-commerce site ran on a single monolithic application that was supported by many different development teams. As the size and the number of teams grew, the ability to deploy new features and services became a challenge. Teams needed to coordinate releases. When components changed, the dependencies between them were sometimes broken. Quality decreased as a result. The company decided to transform its model. Each team will be responsible end-to-end for delivering the service. This means that everything from requirements through operations will be owned by the same team. The idea of a two-pizza team means that all teams should be small enough to feed with just 2 pizzas. The idea was implemented because the finding that as a team grows, productivity affected the overhead of communicating and aligning people. Also, if services must communicate with each other, then they must communicate through well-defined APIs. That way, teams are free to work on the implementation details of their service at the necessary pace. The team does not need to worry about breaking dependencies. Teams release software faster in this way. This is the development process Code Pipeline supports. With Code Pipeline, you can configure your workflow and integrate it with AWS services and standard CI/CD tools like Jenkins and Git. In this 3-stage pipeline, source actions continually poll service providers to detect changes. When the service detects a change, it creates a new pipeline instance and runs it. The source actions also place the source information in an S3 bucket. Code Commit is a private Git service managed and provided by AWS. You don't need to provision servers or infrastructure for your Git repository. It is a managed service. Code Commit provides secure Git source control service built on a cloud scale architecture. You can push and pull from the Git repository using the Code Commit CLI. You can also use other Git GUI tools. Instead of using a file system-based implementation, the repository data is stored in Amazon S3, and the index is actually stored in Amazon DynamoDB. The repository data is automatically stored across multiple availability zones, which provides enhanced data durability and service availability. Data is encrypted at rest using customer-specific encryption keys that are stored in the AWS Key Management Service. Code Commit integrates with identity and access management, where you can assign permissions to your repositories in the same way that you assign permissions to other AWS resources. This concludes the discussion on CI/CD. Thanks for watching.